How's it going, everyone? Welcome. Elier Gonzalez. Today, let's take a look now at the model pattern, particularly understanding is the closure. And how do we get here? By reading the book, the You Don't Know GS series yet, the You Don't Know GS yet series volume 2. And here, in this specific book, that now Kyle Simpson on the first book actually make a quick recap of how do we get here. So about the name of the JavaScript, the author, who owns the legal trademarks, and now who oversees the technical spec. That at the end, we also look at the process of how now a proposal or champion works all the way up to the top until it is accepted as part of the proposal, as part of the spec. And once that's done, because now it is turn for browsers to implement those features, some of them might or not do that, right? Or they do that in their own pace. So because of that, uh, well, there are things known as polyfills that allow you to use now these new features, while browser find ways to provide those implementations in the browser. So this native built-in logic and behaviors. So I also look at the different JavaScript environments that we can run. For example, not only the browser but also the server, and specifically the dev console. That it is not a JavaScript compliant spec environment. It's more like a JavaScript friendly environment. Why is that? So for example, when you analyze behaviors like uses strict and hoisted, this actually doesn't work or behave like in any JavaScript environments. So the concern around the JavaScript, it is scriptic nature, is not a fast enough language. It shows that back in 2011, 2013, a bunch of Mozilla engineers say, hey, you know what? Well, we poured this Unreal game engines to JavaScript by having this subset of JavaScript that targeted specifically to the JavaScript engines to do optimizations, right? So now they show that JavaScript indeed is a fast enough language to run this JavaScript or to run this application written in another language, and now pour that into the browser and run it. So years by, now the spiritual successor of this experiment, the ASM, no, the ASM.js, as they put it, as they call it, is now, hey, let's go to now, instead of actually target directly or define its directive specific for this engine, let's go to now is skip the parsing phase and create an immediate language or a immediate representation of the language that is now capable of run code in native language, right? So the output of this code is close to machine. So this is when we have, for example, WebAssembly, where now here you can now pour several applications in different other languages to this intermediate representation known as WebAssembly and or WASP. And wherever you have now a WebAssembly environment that you can run it, you can now execute this code. So that becomes quite interesting. And for example, applications like Netflix and so on and so forth, they actually now are heavily used on this as a way to run or process certain files, right? So whether it's video or audio. So any of this file processing has become very, very useful to not only to process but also to send over the cable, right? So also I look at another particular thing known as the user strict, which tell is now JavaScript developers that it must follow certain rules that have a good chance of optimizing and running your code, right? So this is the getting started of the first book that Kyle Simpson described, and when I went through that, it was mind blowing because first I didn't know a lot of the things. Second, it makes a lot of sense to now create this narrative that is based on the reality, based on the facts, that makes a lot of sense as the mind and how the mind is seduced, right? In terms of how it learns, how it's captured the mind. In look at the other aspect now, the technical aspect of the language. So, for example, is that hey, what is a program in JavaScript? How a program or how JavaScript sees a program, how you can make all of these different programs to cooperate among them. And also is that how JavaScript actually now is interpreted this language or processing this source of text into something that can be understood by the machines. So usually we think that JavaScript do it is dynamic nature, it is a scripting nature, it is evaluating line after another. But in the case particularly of JavaScript, that's not true because, well, JavaScript behave much more like a compiled language when it analyzes code rather than when it executed, right? Or generated. So because of that, I also look at, well, what is the anatomy of a program that is made of values and what these values represent, which is the state of the applications. What are the different states that we can have in our applications that we can represent? Well, we have now is the primitive objects or the primitive values. So whether it's a string, a number, and how now they are represented, they follow a particular standard. In the case of the number, it has the IEEE 7051, 754, and they also, that particular spec has their own limitations due to the nature of how now numbers are arranged, okay? And also because at the end of the day, we are dealing with limited amount of memory in our computer. So 50 years ago, for 4 kilobytes was amazing, was huge, was mind-blowing. But now, 10, 20, and 30 gigabytes is something that is not that huge, right? So the point here is that memory is a constraint, and because of this, well, we need to have some way to represent that. And because we cannot store long numbers, at some point we need to cut it off, input it and store and represent that in our memory, right? So that's what we have, for example, 0.1, 0.3, 0.1 plus 0.2, you have now this 0.3333. Again, some details that I don't want you to get lost here. And the other is the string, the Unicode format. Before this Unicode, we have the ASCII that only represents Western characters. Well, why is that? Because this was developed by U.S. companies and U.S. institutions. So the represent, of course, is, well, the English language. But as their industry grows and reach other different cultures, so not only on the West, so South America, Europe, but also is on Africa and the Middle East, and Southeast Asia, and China, and Russia and Australia, and New Zealand. So each one of those cultures, some of them have a particular way to read content, one, and how now they represent its characters. Okay, so this is why we have now the Unicode. Unicode is a particular format that is 6-bit long, right? So in other words, you have now 16 zeros representing now is all of the basic multiplane, aka all of the possible symbols in the human language possible. That I do think that's quite mind-bending. You know, if you when you have the time, you can take a look at that basic plane that is telling you is all the possible character for Western cultures in Middle East and Hans-based character, which is somewhat like Chinese characters, and South Korea, Laos, yada yada yada. You name it. And also is Jesus. In African symbols and also Mongolian. It is, my friend. It is when you have the time. It is huge, bro. Or girl. It is huge, sister. It is huge, bro. Okay. So, because of that, okay. Anything that go beyond this is known as the astral plane. This is where you can have things like emojis, combination of emojis, so on and so forth. So another primitive is the boolean and the symbols, as well as the kind of emptiness like undefined and null. Okay, and a big int is another one. And the other is the objects. And objects allow you to represent now is like a hash table, aka like a table of two columns where you have now the identifier and then you have the values. All right, so you can now map this data, or you can have now sequence of elements, right, where you can inside of this position of the element set some primitive values, hash values, or even arrays of values, and also functions. So I hit the brake here in the functions because when we understand now functions and the role and the important role of function here in JavaScript, right, which is that allows you to now is to develop application in this functional approach. So because JavaScript do it is inheritance, it now is, or it was, and it still be influenced based on all of the R&D from software computing. So from procedurals, how you can write programs like a procedures, or how you can now write programs like a functions when computation is the only thing that you care about, or how you can now make a program that cooperate with another ones, right? So for example, in the case of the objects, so object-oriented programming, functional programming, and procedurals, all of them are part of the approach when we can write our programs. So I do think that's quite interesting, mind-blowing, revealing, because especially with the functions, I also look at how you can define a function, whether it's a function declaration or an expressions, how also you can now is use something called as variables to contain those values that allow you to represent in the state of the application, and then you can now is have several of them. So functions, var, let, and cons. And because this is a huge overview of the language, also how you can work with these values, aka how you can compare with these values, if they are the same type or if they are the different type, right? So what's going on? What is the algorithm that allows you to process to generate is an output, and also how you convert one value to another one. That's mind-bending, bro. That's truly mind-bending, truly mind-bending, right? So, so, right? So because of that, right? As we explore is also how can we organize is our code. So now that we know what a program is, what values are, and variables, and why do we have variables, and how we can now rearrange our programs in a way that is easy for us to maintain and to extend, whether it's per functions or per modules like ESM or CommonJS, and also as classes, all right? And then look at the low-level details like the iterators, what now is iterable or an iterator, what this allows to us, which is instead of having us to manually or to be explicit about how we can consume our data, we can now rely on these built-in behaviors that allow us to now is just with a small key taps to use and iterate to data or values that can be iterated over. So for example, string, map, set, which is another data type as well, and array as well. Or any other object that implement is the iterator protocol. So far so good, right? And also is the anatomy of the function. So for example, what a closure is, what this value is, and how they behave, right? And the anatomy of an object, okay? So here we're describing is the anatomy now is at the specific, is the anatomy of these specific values. So the functions and the objects. And also is on the array. Something that in this book they don't talk about that, which is the asynchronous nature of the language. And I know that they don't talk about because this is, it will, Carl Simpson have a section that it was, that it has a draft section where it put now is some to-do things, but it turns out that it didn't hit the milestone to from his crowdfunding campaign, so that's why he stopped that. But in my case, I do find that this is important to mention as a way to now open a door of what is the things that we can do when we need to deal with asynchronous value. Why this is important? Well, because especially if you're building now web applications where now computation is not on your machine, it's on other different machines, right? That in the case of Amazon's or Google or Azure, now they provide you some computation power that are not even closer to your location, right? They might be is 1 mile or even 100 miles away or even in a different continent, okay? So in order to access to those computational resources and memory, all right, now we need is to, well, find a way of how the software industry actually deal with this issue, and now what are the current proposals in, so what are the current tools that we have and the current proposals to make these things much more easy to manage, right? So first we have now the callbacks, right? And it's important at least to make this distinction, which is what is concurrency and parallelism. So parallelism are multiple tasks that run at the same time, And because now we need to communicate with different services, for example, a database or an edge catching, which is a computer that is close to the user's locations to serve content and reduce the latency. And the other is the storage services to hold now images and videos, security servers that actually now make sure that no bad actors can abuse of your resource, so on and so forth. Okay, so in order to access these servers that are not in your machines, so we need to is somehow is wait for those servers to communicate, right, and wait for their response. So this is something that we did with callbacks, right? And with callbacks, the trade-off is that despite that we are passing is a set of instructions to a function that is going to now execute that call to other services and wait for that and wait for them to reply. So the thing here is that if you're talking to several of those servers, now it becomes a coordination problems, especially if one service rely on another, right? So if one service is depending of another one. And a good example of this is let's say we're making a fintech, right? So fintech are are their new orange. So this application that you're building, okay? Let's say you have now a user database hosting in different locations, right? You have the user database, you have also the transactions database, and you also have is the movement, let's say of the transaction, right? Just to make it simple. So you have now two services that you want to know more about this and store this information. So for some reason, if you now wants to know is the transaction that happens in the last 3 months back in November 2024, okay, so you have to now is hit the user, retrieve the relevant information, and once that is done, now you need to is check out the transaction database, okay, to actually see and query the data from that period. Good. So once you have all of the data, you need is to, well, coordinate some couple of things. So for example, hey, what happened if this servers, what happened when I query users, for some reason it fails, okay? So I need to, well, find someone to fall back. And the other is, so okay, now that I get users, what happened when I need to is wait for the transactions, okay? And if the transaction query fail, how can I fall back, right? Or do some rollback. And yeah, that's pretty much a challenge in itself. So this particularly problems of coordinations, especially when you have to wait for them. So thunk is now the ability that a function to pass now to another function that is going to hold that information. And I would like to understand that the thunk concept here. Let me actually put this. So thunk here, the thunk pattern, okay? Because what you're doing with this thunk is to say, hey, let's going to now inject a subprograms into another subprograms where the primary thing is that we need to hold some computations, okay? Whether it's that you want to is insert some computations to that at the beginning or at the end of that. So in any case, this thunk what allows is to hold some computation, and then once the data is there, we can now execute this callback or these subroutines as they like to call, right? So I also look at how can we create is this sync thunk and also async thunk, and now how thunk becomes now is a program or a functions that allows to hold is this async computation or synchronous computations. Uh, and when we call that as an instance, now it's going to handle that for us. So here what we're doing is just abstracting is thunk and get rid of the time as a concern, which is huge for that. And again, I don't know what they're smoking when they did that thing, bro. But it turns out that actually works. And something that is now embedded into the Redux and Redux toolkit, right? So there are other type of applications that they don't rely on this kind of patterns, right? So for example, substance and yeah, for example, substance and how do you call it? Yeah, so substance and Jesus. What's the other one? Yeah, substance, um, recoil. There are other libraries in the React ecosystem that allow you to write this user interface and respond to user events to do so. Where, well, uh, now there are other libraries out there that are not relying on this pattern here, but they are relying on other patterns. So, but in any case, after we look at the thunk, and what the thunks allow us to is to now hold this computation into a variable that already is being defined, and when we invoke that thunk, we are now going to be is execute that functions, and once that is done, we're gonna get is the value out of this. So and then I also look at the promise. Okay, so promise now is pretty much like when you're dealing with events. So in other words, is now for dealing one single eventual value. All right, so you get rid of the time as a concern, and the other is the coordinations, because now all of it has been handled that for you using this native built-in yeah, this native built-in tool, right? So with promise, now the only thing that you're gonna do is of course create the promise, which are going to now allow you to execute is this particular callback when the data is available, and then you can now change several computations on. So not only is great for one single computation, one single eventual values, you can also is dealing with a collections of single eventual values, right? So now it makes much more sense and easy to work with functions here or a user here. Jesus. For example, in the case of the bank or the fintech app, so it's much more easy to deal with the Jesus. Yeah, it's much more easy to deal with is the how do you call it? Jesus. For example, is hitting the or querying the user's database, and also with the transaction database, and if something went wrong, now you have now mechanism to handle those use cases known as the catch. So again, I don't want to dive deep too much into this. Just want to mention that this is now how can we deal with single eventual values, all right, and also is something called as a generator that allow us to now is have control of the function internal execution, aka so you can think of this at any time that you execute a function, because that is a non-stop execution. It go from the first line into the end, right, or until it hit a return. So now we have this ability to control if the inner execution to pause and resume is the function execution known as generators that is open up the door of how you can now code that looks like synchronous when you're writing asynchronous applications, right? For example, async and await is a good example of that. And then the way of how you can deal with series of eventual values. So you have now one single source, and that source is not only is emitting one value, but is emitting is a series of eventual values as a stream of value. Think of this like a broadcasting, right? Or for example, this Twitch and YouTube and so on and so forth, right? When they go live, right, they are now sending is several of this image per second, right? A rate per frame. And that's interesting. So that's why you can see all of this image actually moving, and you can think that the other person actually is live. So how you deal with this kind of things, right? So for that we have now the observables when now the problem is to dealing with this single source that is a streaming series of data. And with observables it allows to, for example, is now known what it allows us to define is these observables, right? Observables based on the primitive values or the object values, and also with the promise values. Okay, so that's quite interesting. I go beyond the scope of today's video. RxJS is one of the libraries that is heavily used for that. It also was developed by Microsoft team, similar with the TypeScript. Again, because Microsoft has some particular challenge, especially when dealing with this asynchronicity. Okay, and that is quite mind-bending. They actually come up, or the engineering team come up with this sort of solutions. Well, that's what it is. That's now becomes now a standard on JavaScript, right? And also is something that is used in programming in Go, that is known as CSP, which is the communication sequential communicational sequence processing. I do think the system like that. Communications, this one. This communication sequence process. Okay, which is, of course, I am not quite familiar to this. And again, this is a formal language. And now, unlike is the observables and promise, that promise actually is based on a mathematical foundation. So for example, if we look now at promise, okay, promise in JavaScript, what is the underlying mechanism? Okay, exactly, or what is the underlying mathematic? All right. All right. Mm, mm, mm. Exactly. Anyway. Well, okay. Is is um mm, 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 is or are promises monads? Monads? And here is when things start to get quite weird, bro. A promise in JavaScript, while I consider to be monads, due their ability to encapsulate synchronous computation and support composition through bind-like operations, typically implemented via .then, right? According to this particular website. However, some analysts argue that JavaScript are almost monads. And here, I just want to briefly mention that because this is not what is today's video, okay? This video is more about from the JavaScript perspective developers, okay? So what are the things that are relevant for JavaScript developers? But I do think this is at least important to understand where all of this theory or where all of these built-in values are coming from, all right? What is the standard it follows? And that is the functional programming, right? Is functional programming. Right now, I'm not gonna read this because it's a lot of gibberish to me. But again, it's a monad, right? And here, this is quite interesting because monad enter into the category theory. All right. In category theory, okay, is a general theory of mathematical structures. And when you talk about mathematical structures, is a set of or some set reference to providing or endowing it to them with certain additional features, operations, relation, metrics, and or topology, right? Interesting. So the additional features are attached or related to the set or to this or to the sets, so as to provide it or then with some additional meaning of significance. A partial list of possible structure is measures, algebraic structures, topologies, metric structures, orders, graph, events, differential structures, categories, setoids, oh what the fuck, an equivalence relationship. Sometimes a set of is endowed with more than one feature simultaneously, which allow mathematicians to study the interaction between the different structures more richly. For example, an ordering imposes a rigid form, shape, or topology on the set, and if a set has both a topology feature and a group feature, such that these two features are related in a certain way, then the structure becomes a topological group. A map between the two similar structures said that the preserved structure is known as morphism. But again, it is about a structure on a set, right? It's a collections of different things here. So in this case, this mathematical structure, this collection of these different things, whether it's a hash, whether it's an array, or a function, okay, and the relationship, it was introduced by Samuel Eliber, holy moly, and Saunders MacLean in the mid 20th centuries in their foundation work of algebraic topology. Okay, category theory is used in most areas of mathematics, in particular many construction of new mathematical objects. Interesting mathematical objects here, from previous ones that appear similarly in several contexts, are conveniently expressed and unified in terms of category. Examples include quotation space, direct products, completions, and duality. Many areas of computer science also rely on category theory, such as functional programming and semantics. A category is formed by two sorts of objects: the objects of the category and the morphism. But again, in other words, in any case, So this is part of the mathematical foundation, right? The category theory, right, is a general theory of mathematical structures and their relations. A mathematical object with different things on that and how they relate to each other. That again is very abstract, unless you have at least one things in common, one more practical application on that, and then you can understand this. So this is what category theory is. Yeah, right. I just want to mention this. The category theory, right, is a theory between these mathematical structures, which is these different things that it has, and how they relate. Okay. And then you have now is the communication sequential process. It's a formal language, okay, for describing patterns of interactions in concurrent systems. So this formal language, which now is introducing, is on the realm of logic. So mathematics, in logic, mathematics, computer science, and linguistics, a formal language is a set of strings whose symbols are taken from a set of alphabet. All right. So here, what you're defining is now some keywords, right? That are part of an alphabet, that is part of describing something. The alphabet of a formal language consists of symbols that concatenate into string, also called words. Words that belong to a particularly formal language are sometimes called well-formed words. A formal language is often defined by means of formal grammar. But again, this is a formal language, okay? But this is specifically to computer science. Why am I mentioning this? Okay? Well, because it turns out that when you need to deal with this sequence of eventual values in these coordinations, so now there is a formal language, okay? Now it's an alphabet for describing these patterns of interactions in concurrent system. So this is mind-bending. This is a mind-bending. So in 1978, article was essentially a concurrent programming language rather than a process calculus, right? So now this is part of this, you know. So process calculus, which come of course from the mathematics, the process calculus of process algebra are a diverse of family of related approach for formally modeling concurrent systems. So you want to now find a way to model up this concurrent system, these systems that now have to wait for some eventual value to be there. And this is known as the process calculus. Mathematics of process. That's interesting. Again, this goes beyond the scope of today's video, but it's important to understand that all of it, so on the asynchronous nature, we are using is some of this mathematical approach, the process calculus or calculus from these computer science techniques and so on and so forth, right? Yes. Yes, the process calculus. Okay. And the other is the category theory, right? Is that how now these mathematical structures are related, right? How they are the relationship here. This is more like for the monads in AKA promise. And here is now how we can model, how we can now define is a form, how can we define is a model to now deal with this concurring systems. So I do think that's quite very interesting to make this quick overview of how do we get here. And a lot of you might say, hey, that's my quite cumbersome. There's a lot of to take, so on and so forth, yada yada. All right. Okay. Cool. Cool. Diggy diggy. You got it. You're here. Okay. Holy moly. That was a lot. I must admit that that was a lot. Okay. And well, and how do we get here now quickly, right? Yeah, let's make it quick. Yeah, let's make it quick. And how do I get here? Specifically in the model patterns. Well, as I make this 45 minutes was to only describe is the essentials, the getting started of JavaScript, and then now we look at attention to the scope and closures, and why this is a relevant and important. Why this is important to know. Well, it turns out that when you're writing your applications, it's important to understand how working with variables and functions are. Okay, so first thing first, I look at working with variables is important because when you define now functions, and because now functions and block scopes are defined by the scope rules, you can think of this like the scope manager, right? Where is defining is how these variables and blocks behave, and all of this is defined is at compile time, not at runtime, so it is not affected by runtime conditions unless you explicitly modify that or you allow it to do that using the eval functions that allow you to now run is code at runtime. Okay, but it's not if that is not the case. Usually, that scope structure is defined at compile state. So when you now hold your functions as value inside of a variable, and you now have all of these variables inside of this function, the resulting scope structures is going to be the same. The scope structures remains the same at runtime, aka forming is a closure. So after that, I look at briefly how now is, so to understand now the closure is, well, first thing first, understand now the classic compiler theory, how you now in a compiler language which is going to analyze your source text in generate a code. You have three phases. You have now the parsing and the lexing, that is taking all of these streams of characters and convert them into meaningful tokens. And with all of these streams of token, now it's going to define its relationship. And the second phase on the parsing, and the phase 3, okay, which is once the abstract syntax tree is created on the parsing, now the computer knows what is the code that it needs to generate in this portable binary format based on that platform. So whether it's an RM or a 66, you name it, right? So because now the point is that when you look at how JavaScript behaves in terms of how it analyzes syntax errors or syntax errors, okay, how it analyzes syntax errors, how yep. Anyway, yes, how it analyzes syntax error, right? Oh my god. Yeah. Anyway, how it analyzes syntax errors. How we analyze syntax errors, early errors, and scoping, it behaves more like a compiled language rather than an interpreted when it analyzes code, not how it generated, right? So I also look at, well, a little bit more of the technical aspect of the left-hand side or right-hand side, which is when the assigning of a variable, assigning a value to a variable happened, whether it's from the target and from the source. And this is important to understand that because as we explore of the scope and how this scope is created, whether it's by block or function or even global scopes, when you create that using a function or block, internally it has now a reference that points to the outer enclosing scope until it reaches the global scope when there is no more, when the pointer is null, okay? So when there is no more outer reference. So I also look at now how the blocks go work, now how the functions go work, with the other scope that we can have in the language, for example, and the parameter scope. It is, at least don't mess with that, right? It is important to understand that. If you want to find yourself and experiment with that, I'll encourage you to do that. But on the practice, in the industry, we don't actually mess with that, okay? In the industry, it's actually wants things that are quick and dirty, take it, quick and dirty. So that's good, right? That's good. That's great. All right. So also understand is why we emphasize or what we care about is function name definition over arrow functions, because now they are lexical available, okay? Which means is that first you can access to that function. Second, you can use the name descriptor to say what this function is all about. As we explore also is now how this scope change works and how this scope change is created, You can think of this like going into an elevator and take a look at all of these different floors to verify if an identifier, a variable, now live there. All right, and then I look at the other global scope, the window or the browsers, and how now they behave when you're using functions and var. They are hosted, but not with let and const, or they are attached. Those identifiers are names are attached to the window global object. How the window global object behaves. It is exclusively for handling is the UI, right? If you want to defer some computations, you can use this now the web workers, right? To handle this some heavy lifting computations that are not relevant for the UI, right? And how the service work is also is an environment in itself. You have access to the global object via the self. Functions and var also are attached. The identifiers are attached to the global object. That's not true for let and const. And also is the common GS and the ES6 model, which is the way of how now code is organizing in older versions of Node. And you can think of this like a function of passing is parameters that are now available on that function, right? And now in the ES6, right, because there is no notion of global objects, so you cannot attach or identifiers, name identifiers like functions, var, let and const are not attached to the global objects. But if you are now in the node environments, you can be explicit about what are the global variables that you want to attach to this, right? So they can be accessible across your entire application. So far so good, because as we also explore now is how these variables work, the life cycle of variables here, by looking at the way of var and functions behave when you define them, right? And they are now hosted, so their values are put at the top, and in the case of the variables with undefined values, and on the function with the function values, all right? And that's not true for let and const, okay? So let and const now they are block scope, where var and function are function scope, and also now how these variables identify, or these variable keywords, they behave with looping syntax. So for example, do while, and for, right? And how now the for, especially when using var and with let and const, they behave particularly because, well, var is globally or function scope, where at less it blocks scope, and also with const is also a block scope. So because with const, you need is to define the variable and assign that immediately when you define it, right? This is not true for let. You can define an identifier, but you can redeclare that identifier, but you can assign a value later on. This gap is something, or when you're trying to have access to an identifier before it is definition, it throws you a error known as the TDC. This is not exclusively to let and const. This is also true for variables, because at the end of the day, if you're trying to access to an identifier that is not defined at that moment, it will throw you an error. So knowing this nuance and the life cycle of variables, then we shift our attentions to a more to decisions and patterns that we need to apply across our programs. One of them is the least of the principle of least exposure as you're starting to write your applications, right? And make it easy for us to understand and to write and yada yada yada. It is important for us to now limiting the scope, the overexposure scope of that, and by doing so, okay, we eliminate an entire classes of problems. So one of them is name collisions, unintended dependency, and unexpected behavior. This unexpected behavior is solved with TypeScript. The unexpected dependency is also solved with TypeScript, but the name collisions will remain, right? So what are the tools that we can have to deal with? Well, you have now functions, which is the immediately invoke function expressions. Yeah, exactly. You can use these immediately invoke function expressions, right, to save some names in your applications, right? And also is to avoid to overexposing is variables that you don't need in that particular scope, right? When to do that, it is up to you to decide when. And also is avoid to put now is functions inside of if block, because now it is quite hard to test that, and the idea is to avoid tripping up about your code, right? We don't want to trip about, I don't want to trip about my code. So after that, all right, well, now when I shift my attention again to a broad high level thinking, is when you analyze now to the functions and the anatomy of the function, especially of the closures, all right, is when you're starting to now referencing variables that live on the outer function scope inside of here, and then you want to execute that functions in a different scope chain from the variable that you are referencing. So you are effectively creating is a closure. So closure has the several approaches on how you can think or look at that. But the TLDR is that closure is when you need to keep track of a data or of a piece of information over time. That's the core of this. That's why we look at closures. When you need to keep track of a piece of information over time, you want to hold that, right? So instead of you computing that value on any invocations, you already have that pre-computed, okay? And if you want to update that, well, you define some sort of methods that allow you to interact with the data. But this data is now hidden. You cannot access to that unless you expose directly that. And this encapsulation of this detailed private information that you're keeping over time is the core of the closure. And also we need to look at how can we create a closure, what are the trade-off of closures, because now these variables reference are not garbage collected. We need to create code that makes that possible. Okay, so that's the whole overview of closures. And now finally we are here. Okay, so in this chapter we wrap up the main text of the book by exploring one of the most important co-organization patterns in all of the programming, the model. Okay. In this chapter, we wrap up the main text of the book by exploring one of the most important co-organization patterns in all programming, the model. As we will see, models are inherently built from what we already covered, the payoff of your effort in learning lexical scope and closure. We have examined every angle of lexical scope, from the breadth of the global scope down through the nested global scope, or to the nested block scope into intrinsicies of the variable life cycles. And then we leverage lexical scope to understand the full power of closure. Again, I make this entire narrative just to make sense of how do we get here, but the truth is that you need to read about is the spec and how the things change, especially on the proposals. So if you are able to keep up with the JavaScript trend, you're all good to go. So yeah, we have examined every angle of the lexical scope into the intrinsicies of the variable life cycle. Then we leverage lexical scope to understand the full power of closure. Exactly. Then we leverage lexical scope to understand the full power of closure. And take a moment to reflect on how far you have come in this journey so far. You have taken big steps in getting to know JavaScript more deeply. The central theme of this book has been that understanding and mastering scope and closure is key in properly structuring and organizing our code. Absolutely. So understanding is the lexical scope in working with variables and understanding closure is the key to proper structure and organizing our code, especially the decisions on where to store information in variable. So our goal in this final chapter is to appreciate how models embody the importance of these topics, elevating them from abstract concepts to concrete, practical improvement in building programs. Encapsulation and the least exposure. So encapsulation is often cited as principle of object-oriented programming, but it's a more fundamental and broadly applicable than that. So what are the encapsulation? So encapsulation allow me is to now hold something, in this case an information, right, and make it private too, right? So only those who can have access to that encapsulations can look at that. Anybody else does not. So this is what encapsulation is offering here, right? This encapsulation is offering is a security here. Security and portability of the code. So the goal of encapsulation is the bundling or co-location of information and behaviors that together serve a common purpose, independently of any syntax or code mechanism. So I don't care how you're going to implement that, but the thing that I care is that I hold this data and the behaviors and the functionalities, right, into one single bundle that serve, of course, a common purpose. So the spirit of encapsulation can be realized in something as simple as using separate files to hold bit of overall program with common purpose. If we bundle everything that power a list of search results into a single file called searchlist.js, okay, we encapsulate in that part of the program. The recent trend in modern front-end programming is to organize applications around component architecture push encapsulation even further. For many, it feels natural to consolidate everything that constitutes the search result list, even beyond code, including presentational markup and styling, into a single unit of program logic, something tangible that we can interact with. And then we label that collections the search list component. Another key goal is the control of visibility of certain aspect of the encapsulated data and functionality. So this is the two things that I mentioned, is that it allows me to now is hide this information, right? And make it easy to carry over that. It is portable. So recall from chapter 6, the least exposure principle, which seeks to defensively guard against various dangers of scope overexposure, These affect both variables and functions. In JavaScript, we most often implement visibility control through the mechanism of lexical scope. The idea is to group alike programs, bit together, and selectively limit programmatic access to the part we consider private details. What's not considered private is then marked as public, accessible to the whole programs. Exactly. So there are private details in our programs, and what is marked at that, it is public. The natural effect of this effort is better co-organization. It is easy to build and maintain software when we know where things are, with clear and obvious boundaries and connection points. It is also easy to maintain, qualify if we avoid the pitfall of overexposed data and functionality. And there are some of the main benefits. These are some of the main benefits of organizing JavaScript programs into modules. And what is a model? So a model is a collection of related data and functions, often referred to as method in this context. Okay. Characterized by a so in other words from this, so what allow is this module or this encapsulation is to have now all the relevant data and its functionality in one bundle, so you can now is pour that in any place of your application, right? But now the entire functionality and data live here, right? And if you need to extend that, you can do that, right? If you need to extend that, you can do that. But again, it's going to live, so you can now pour that into different part of your programs, and also into other programs as well. So what is a model? A model is a collection of related data and functions, often refers to as method in this context, characterized by a division between hidden private details and public accessible details, usually called the public API. A model is also stateful. It maintains some information over time, along with functionality to access and update that information. A broader concern of the model pattern is fully embracing system-level modularizations through loose coupling and other programs architecture techniques. That's a complex topic well beyond the bounds of our discussion, but it's worth further study beyond this book. So so this is now exactly, because now if you're talking about single thing, search input, right? Where all the data and the functionality live together here, and you can use that functionality, the programs, across different part of your applications, right? If you now think big, a broad concept of the model pattern is fully embracing into system level modularization. So now it becomes now the front end and the back end and all the other services, right? Where all of this code will live here. And if you want to now pour these applications to other different applications, you can do that. This is what containerizations, Dockers, and all that kind of stuff are there here. Okay, all right. okay, good. Absolutely, bro. Absolutely. Okay. All right. Okay, to get a better sense of what a model is, let's compare some model characteristics to useful code patterns that aren't quite models. Namespace, stateless grouping. If you group a set of related functions together, okay, to get a better sense of what a model is, let's compare some model characteristics to useful code patterns that aren't quite models. So namespace is a stateless grouping. Okay, so I don't care about the state. Stateless grouping. Okay. So you only define is the functionality there. The other is the data structure, which is a stateful grouping, right? So you have now is the data there. And some functionality. But again, this is the data structure. This is not a model, especially because it doesn't follow is the principle of least privilege. So it's exposing everything. Okay, and the other is a model, which is a stateful access control. To embody the full spirit of the model pattern, we only need grouping a state, but also access control through visibility, private versus public. And let's turn students from the previous sections into a model. And we'll start with a form I call the classic model, which was originally referred to as revealing model when it first emerged. I do think that it'll Mm. Mm. Yeah, that'll be all for this video. That'll be all for this video. Take care. Bye bye.